Have you ever believed that two things are connected, like how people think eating chocolate always leads to acne, only to find out later that there's no real evidence linking the two? That's covariation bias in action. At its core, covariation bias is our tendency to perceive a relationship between two variables, even when there isn't one. Our brains crave patterns and connections, and they're constantly looking for clues about how the world works. This tendency can be helpful. It's part of how humans have evolved to survive. If our ancestors noticed dark clouds often led to rain, they'd seek shelter before getting drenched. But as useful as this instinct can be, it also leads us astray when we see patterns that don't really exist. For example, take the infamous belief that full moons cause an increase in strange behaviour. From crime spikes to hospital emergencies, the full moon has been blamed for it all. Yet, study after study shows no consistent evidence of such a link. So why do so many people believe it? Covariation bias plays a big role here. When something unusual happens during a full moon, people remember it vividly and associate the two. On the flip side, when strange events happen during other phases of the moon, they're less memorable and don't leave the same impression. This bias is further amplified by confirmation bias, another cognitive shortcut, where we tend to notice information that supports our beliefs and ignore evidence that contradicts them. Together, these biases can form a feedback loop, reinforcing our mistaken assumptions. But covariation bias isn't just about quirky superstitions. It can influence major decisions in health, education, and even public policy. For instance, in medicine, covariation bias might lead someone to think a specific alternative treatment is effective simply because they felt better after using it. They might overlook other explanations, such as the placebo effect or the natural course of their illness improving over time.